Alright, welcome back folks. We're going to talk about summation notation today. This is 10.1.4. The capital Greek letter sigma is used in mathematics as a shorthand notation to indicate the sum of a series. Sigma means to sum up, or just to sum. And it gives us a little more information than we had without sigma. Namely, it tells us where to start summing and where to end summing. So if we have this written like this, we're going to sum from the first term to the fifth term for this series. So it tells us 2k minus 3 is our series equation. So we're just going to plug in t of 1 plus t of 2 plus t of 3 plus t of 4 plus t of 5, and that should equal 15 in this case. So we're summing from k equals 1 to k equals 5 for the terms 2k minus 3, and it equals 15. So we could look at another series here. If we had 1 squared plus 2 squared plus 3 squared, and we just wanted to sum those three terms, then we could say that we are summing k squared from k equals 1 to k equals 3. So then we have our 1 squared plus 2 squared plus 3 squared, which would be the same thing as 1 plus 4 plus 9, and it should equal 14. We call k the index and k squared the argument. So that's the argument. There's the index. The values of the index are always consecutive integers, so the values of k in this example are 1, 2, and 3. Let's look at another advantage of summation notation. Up until now, if you've had a series that looked something like this, let's say we had 3, 6, 9, 12, etc., etc. So we have a common difference here of 3. If we wrote that equation out, we would have 3 times n minus 1 plus 3 would equal t of n. Up till now, we've had to start with the first term and go until the kth term, whichever one that was. But if we use summation notation, that'll let us sum between other segments in the series. So we could sum, say, from n equals 5 to 7 of this equation, 3n minus 1 plus 3. And that tells me that I'm going to sum from my fifth term to my seventh term. So if I plug in t of 5 plus t of 6 plus t of 7, that'll give me the sum over that range. All right, guys, thanks for watching.